Hello everyone. Our today's topic is deduction of Coulomb's law from Gauss law. In the previous video we have discussed about Gauss law and its proof. Now this law is used to derive the Coulomb's law. Okay? So for this consider a point charge say plus q placed at point O. Now imagine a Gaussian surface in the form of a sphere with center at point O. Okay, let the radius of the sphere is say r. Okay, now consider a point P on this Gaussian sphere or Gaussian surface. We know that around a point charge q at a particular distance, that is on the surface of this sphere, electric field remains fixed, or we can say, and this electric field always perpendicular to the surface. So we can say this arrow shows the direction of this electric field. Okay, now consider a small surface element around this point P. Say this surface element is ds, then the direction of this area element is perpendicular to the surface, that is represented by a vector n cap. Okay, so it is clear from the diagram that electric field and n cap are in the same direction. So from Gauss law we know that the electric flux is 1 by epsilon naught times the total charge. So we can say from using Gauss law we get phi must be equal to q by epsilon naught, or we can say phi means surface integral of electric field means E dot ds must be equal to q upon epsilon naught. As E and ds are in the same direction, so we can say E ds cos theta, this theta will becomes 0. Okay, as both are in same direction. So we can write it as E ds integration over surface s must be equal to q upon epsilon naught. Now as at every point of surface E remains same, it means constant, so we can take it out from the integral. So we remains with the E integral of surface element ds is equal to q upon epsilon naught. As this is the surface integral of this. Now as we consider the surface is a spherical, so the integral ds is the total surface area of this sphere. So we can write it as E into 4 pi r square, that is the surface area of the sphere, which is equal to q upon epsilon naught, and E must be equal to this becomes 1 upon 4 pi epsilon naught r square into q. Okay, so this is the value of electric field at point P. Say this is equation first. Okay, now if we place a point charge, another point charge, say q naught at point P, then this charge must experience a force of attraction or repulsion due to this electric field. So this force is given by force on charge q naught is given by, that is F must be equal to q into E, or this charge must be q naught into E. Now putting the value of E from equation 1, we get F must be equal to q naught into q upon 4 pi epsilon naught r square. So we see from this that force is equal to 1 upon 4 pi epsilon naught q into q naught upon r square. This is a well-known relation that is called Coulomb's law. So this is all about the Coulomb's law from the Gauss theorem. Thank you very much.